mark the spam. Oops. Got it solved. It's getting there. Okay. Yes. Okay. It should be there. Yeah, we'll do check.
This presentation should be good.
Mm-hmm.
Just follow the number 21, 22.
You made it to. So are there clicks or just see?
Good morning. Apologize for
second.
Yeah.
Good morning. It's Friday routing working group session, and we begin with.
Yes, apologize for delay. This is an update on the work what we were discussing in VFD working group, and in course of the presentation, I'll try to explain why I think that it might be interesting for the Rtgwg group, not only for BFD group. So we are all well familiar with the BFD and the specification. It's a very successful development design of the protocol that being deployed in many networks over different transports, IP, MPLS, through the wire. So we are, people are working on applying it to overlay networks, but now and then, especially in the BFD group, since we're the core for their BFD protocol, there are proposals and discussions about some extensions to BFD, for example, to monitor the quality of BFD session, because BFD as a fault failure detection protocol has some leverage of how many messages in a row it has to be missed in order to detect failure. But what might be of interest is that to know, for example, if detect multiplier is 3, so how many really messages did we miss? We are receiving constantly each and every message, or we start missing 1 or 2 messages, but then third message arrives and, well, okay, we keep the session up. Again, there are some proposals just to evaluate the performance and path MTU because BFD designed to be lightweight and efficient. It is only a very small control message, but there is interest to see if we can do something more with it. So here's we came up with some ideas of how we can make BFD extensible, and another motivation was that we had very interesting discussion on authentication in BFD. Authentication in BFD is a sort of a, you configure it and you must do it on each and every packet. So if you can imagine if BFD interval is 3.3 milliseconds or at that rate, so that doing authentication in each and every packet in both directions, that's kind of heavy load on the system. There is a proposal that working group completed discussing and progressing further, that to do intermittent authentication for BFD session. But there are some other issues that really doesn't make it always at will. So there are some constraints to that, especially in asynchronous mode. So let's move on and get to the technical details. So the proposal is that because BFD control message does not specify how it's encapsulated in a transport, it only defines the control message. And the size, as I mentioned, it's a fixed, whether it's unauthenticated mode or authenticated mode. For authenticated mode, it's predictable. So our proposal is this, to have a BFD control message again, idea of a guard word just for safety, to separate it, and then followed by TLV, and TLV can have enclosed sub-TLVs, so that makes it extensible. Well, at the same time, of course, might be not as hardware friendly. So to understand whether it's a regular BFD control message or extended, of course, because BFD, at least in IP network, works over UDP, we need to look at the UDP length field in a UDP header. BFD itself has a negotiation process, three-way handshake, exchanging the discriminators. Yes, that handshake can be substituted by some communication in the control plane, and one of the examples is BFD over MPLS LSP, when LSP ping is used to bootstrap BFD session. Another example could be as what is proposed for MVPN to use extension in BGP. There is another example in PMSM for DR-BDR fast failover to advertise BGP discriminator in PIM hello option. What we complement this negotiation is with a capability negotiation between BGP peers. And so they can negotiate loss measurement, delay measurement, path MTU discovery monitoring, and lightweight authentication. And as you notice, each field occupies 2-bit positions, because each of these modes envision be able to support it as part of periodic messages or echo request reply, which is supported by POL final sequence in BFD. As in every capability negotiation, so the active side announces its interest, the other side sends what it agrees to and supports, and then out of that they can conclude what will be used. Performance measurement, the proposal is to reuse encodings defined in RFC 6374, loss and delay measurement over MPLS networks. And the nice part about it is that these messages are allowed to do separate loss delay measurement, direct measurements by collecting counters, and combined loss delay measurement. And because of BFD, these measurements can be either unidirectional or bidirectional. Unidirectional as part of periodic messages, or bidirectional using echo request reply or POL final sequence. And 6374 supports one-way performance measurement and direct loss measurement. So this slide is just an illustration of how encodings from RFC 6374 can be used in this integrated OEM or extended BFD. So we're just using TLV to encode their message that already defined in RFC 6374 for loss measurement, for delay measurement, and for combined measurement. And again, it doesn't have to be sent on high frequency of, for example, BFD messages that monitor path continuity, but they can be sent as part of the POL final sequence. So then the load on the system and it would be not that challenging. Or path MTU monitoring, it introduces basically padding type of TLV, which can have arbitrary length sent to it, and it can be used as for in the proposal BFD large packets set to certain value, and again used in the POL final sequence to casually and time to time monitor the path. One of the benefits of using POL final sequence is that it does not interfere with the more frequent exchange or transmission of periodic messages by each side. And then local policy can set its own rules on when to constitute that link is down, because it could be reaction to not receiving final message once, or just 2 consecutive or 3 consecutive. So it could be a really independent local policy rule. Authentication capability. As I mentioned, the current definition of authentication in BFD applies to each and every packet, and that is quite severe burden on a system that very aggressively monitors path between 2 systems. And the proposal here is that to give the capability of authenticating whether periodic messages, POL final messages, or combination of both. Again, using for POL final messages like in MTU, it gives a local policy opportunity to define the rules when to declare that session is invalid. So this diagram is just a caption of how the lightweight authentication will work in the poll final sequence. And it basically defines, for now, one of the protocols only to use as a hashing function. So the next steps, what we'll continue the discussion in BFD working group, and we welcome your comments, questions, and suggestions. Whether you see any interest or use of this integrated OEM protocol.
Hi, Andrew Gray with Charter Communications. Interesting draft, actually like it. One quick question I had while I was scrolling through it, and I've only had one cup of coffee, so that might be impacting things as well. How does micro BFD play into this if we're doing this across lags?
Micro SBFD, because I'm not familiar with the micro BFD. I know there is a SBFD technology. Micro BFD. BFD over. Good. Okay, thank you. I forgot about it. Yes, you have a better memory. And okay, so again, so BFD over lag spans single hop sessions over each constituent link. It's a good question. I think that might be applicability, again, because this draft allows you, this mechanism allows you to use only these extensions over poll final sequence. Okay, and I think that poll final sequence will go only one, not on each individual lag constituent. But okay, I will have to admit, now I'm speculating. I haven't thought about it. I will.
I would say from our perspective, there would be a fair amount of interest in having that either in the negotiation or the capability negotiation or something like that, adding that in, because a lot of our sessions are over many
Yeah, as I remember this RFC, basically what it does, it just automates creation of single hop BFD sessions over constituents. Session itself has no distinction from single hop BFD session.
Pretty much, yes, but my understanding of it is it's a capability that needs to be distinctly enabled on both sides. So
Yes.
since we're already negotiating basically all the other parameters at the same time, it might be something interesting. Possibly.
My understanding that each individual session comes up individually, independently of all other sessions on all other constituents.
Greg, sorry, it has to interact with min links configured. It's more complex than what you're thinking.
Okay. Okay, but again, as I said, thank you for the question. I haven't thought about it. We'll work on it.
All right, I'll email you as well about it too. Thank you.
And from my perspective, the micro BFD is very widely deployed technology, very useful, and should definitely be considered when you work on the next version, next generation.
Thank you.
Hi, Tony Lee, Arista. As you probably know, we've been trying to get BFD into hardware for a long time now. And of course, this makes it harder. Is there any way we could do this not in BFD?
Well, one of the proposals is to have a protocol which inherits some of BFD nice features like timer negotiation and some robustness, and basically we have a new protocol, non-BFD, which uses a different well-known destination port.
Follow up the question, Louis Chan from Juniper. So will you consider, because I know that it's like a piggyback all the TLV in one package, right? If I'm not wrong.
Not all of them.
Yeah,
I would probably say that I don't see the reason to piggyback. Maybe.
I mean,
Okay,
multiple
if you do some extension plus authentication, yes, you might have 2 TLVs and authentication will be the last one. But I would not see the real need for more than 1 TLV.
Okay, the reason why I asked that because is if you separate the different TLV into different packets, then easier to implement hardware for, the kind of response.
Yeah, and again, to your question, the Tony question, I want to stress that there is no requirement to do it in a periodic messages. All these extensions can work in a poll final sequence. And the poll final sequence usually is processed, well, at least as a bump in the wire. So if not in control plane, then bump in the wire. So okay, well, thank you for your comments, and especially I appreciate the suggestion to look into micro BFD use case.
Thank you. Next up is Shunsuke Homa.
Good morning, everybody. My name is Shunsuke, and I'm a researcher of NTT Laboratories. This draft was originally proposed in CommonSPOF, and it's first time to present this draft in this working group. So I will talk about the digest of content of this draft and introduce our related work in this presentation.
It might be helpful just to be a little closer to the microphone.
Okay, so
A little louder.
okay, so firstly, I will talk about the background of this document. So as you know, devices and services are diversing, and network will be required to apply to such diversity. And network slicing is an emerging approach to apply networks to such diversity. So, and several SDOs are discussing about it, including 3GPP. So, and IETF had started to discuss transport slice. So in network slicing, end-to-end network slice, realization of end-to-end network slice is very important for provide assured communication quality for each service. And 3GPP has a slice subnet concept. Slice subnet is a group of network functions and connectivity, and an end-to-end slice will be composed of one or more subnets. Please note that this definition and terminology are different from one of network slice design team in TIS. They don't use subnet for represent this concept. And so for creating end-to-end slice, stitching of subnets will be required. In addition to stitching subnet, several functionality will be required for creating and provide network slices. For example, slice selection, QoS control, encapsulation, decapsulation, etc. And slice gateway provides such functionality at each boundary of domains. This slide shows the requirements for slice gateway. Slice gateway will provide mainly 2 types role. First is handling underlying infrastructure to create slices. Second is providing controllability of user traffic to tenant. We are assuming that slices will be provided to third parties or tenant, and they use network slices as part of their own service. So some tenant may need to control the user traffic on Slice. So Slice Gateway provides such functionalities. So this matrix lists the requirements for Slice Gateway. So, and this figure shows the overview of Slice Gateway structure. A Slice Gateway is composed of Slice Gateway function, Slice Gateway controller, and several data plane entities. And Slice Gateway controller has two types of APIs. First is for managing slices, and it's connected to the higher level operation system such as orchestrator. And second is for controlling user traffic on slices, and it's open to the tenant. And tenant can control their customer traffic on slices. And in the following few slides, I will introduce related work on Slice Gateway. In MEF, we are proceeding the evaluation test, feasibility test of creation of end-to-end slice across multiple administrative domains. This figure shows a scenario of POC in MEF, and several orchestrators cooperate each other and create Slice subnet in each domain. And Slice Gateway connects the subnets and create end-to-end Slice. This is exhibited in the MEF 2019, and it won award this year's MEF award in this year. Second is feasibility test of VR ping-pong application as future application. So NTT and Rtgwg technologies developed VR ping-pong as and clarifying the what requirement such applications have and how to collaborate application and network. So VR ping-pong is composed of several types of applications. So players, audience, and viewers. Players play ping-pong in the VR space, and you can enter the same VR space as audience and can watch ping-pong game nearby players. And this content also provides video streaming, and you can watch the ping-pong game with tablet or PC. And these applications have different requirements on communication. So for example, player plays ping-pong, and the ping-pong causes high-speed rally. So low latency communication is very important. And ping-pong game is the most important factor in this content. And so the traffic must be protected. On the other hand, video streaming doesn't require real-time communication. It requires just broadband. So we prepare the several types of slices, and game application select appropriate slices. So for example, players start the ping-pong the game, and game server recognize the device has player's load. So request a central request to allocate the traffic to the player's slice, and this content can work even if traffic congestion happens, will occur. So this is just an example of API. So a game application sends request including flow identifier and slice ID. And Slice Gateway controller translates the API to the concrete network configuration and enforce it to the data plane entity. So game application don't require to understand concrete network topology or configuration in this model. So finally, I will talk about next step of this document. So we're planning to breaking down the northbound interface with referring definition and specification of NSDT in this working group. Also, we provide use cases where SLZ or subnet concept will be beneficial. Anyway, so we have very few feedback, and so please read this draft and send your feedback. Thank you very much.
Any questions? Speaking as the design team member, not as working group chair, I'm very happy with your next steps. The step number 1, we are aligning terminology. So for example, it would be highly unsuitable to say it's a subnet. We know that subnet is not what they meant, right? So I would really expect you to use terminology and vocabulary that we have established in design team in your document, and find the right place in hierarchy of controllers, if you wish, where it really belongs with regards to northbound communication to really going down to particular technology.
Yeah, so this document is published in IETF, so the terminology should be IETF friendly. So I will modify the definition to the machine.
Yeah, Dave Allen Erickson. Just a quick question for clarification. I'm trying to understand the relationship between the slicing gateway and the UPF and the 5G architecture and how that relates to the various interfaces.
Yeah, so slice gateway is not a device, so it's just definition. So I provide mapping this functionality to 5G systems.
Okay.
Yeah.
That's in the draft? Okay, thank you.
Chidong from Huawei. Yeah, actually, I think it is very useful to specify the use cases which you have already think about are very met in which can be used for the network slicing and can document it here. This will be very useful.
Thank you.
Thank you.
Thank you.
Next up is Evangelos Halaplidis.
Ready? Oh, yeah. Thanks. So, hello, my name is Evangelos Halaplidis, and I'm closer. Yes. This is better. Yeah, great. So, my name is Evangelos Halaplidis, and on behalf of my colleagues, I'd like to present you our take of forces-based BNG. By the way, my activities are carried with funding provided by the Standardized Initiative from the EU with 780439 program, a grant agreement under the Horizon 2020 program. So I don't know how many of you saw the mail yesterday that the IETF is not going to continue activity on the BNG. Our take is that the IETF has already existing solutions that can address this and can provide solutions for separating control and forwarding plane. Right.
Well, since you brought the topic up, there was a liaison yesterday from the IESG to Broadband Forum that basically said, work on disaggregated BNG had been suspended in the IETF in March, and that suspension will continue until a change in decision is made by a request from BBF or something. So, moving forward, I guess you're saying Forces is a top technology that could be reused, right, for BNG,
yes,
which is good, but based on the IESG's feedback in the future, like we probably won't be allocating time to discussion of this, but so if like BBF wanted to look at forces and say, oh, that's really good, and then request, oh, hey, forces is great, that's fine, but we're not going to be allocating time until there's any change in that.
Agreed, no problem. So what we're going to show is, going to showcase that this is an IETF solution already that can actually support these kind of scenarios. Oh, wow. Okay.
Well, so yeah, I guess it would be useful, I guess, since you brought the topic up, since it would be good to just have a moment of discussion about the liaison statement and so on. I think that's what Dave Senacropia stood up for.
Right, yeah. So Dave Senacrope speaking is the IETF liaison manager to BBF. So yes, that liaison went out from the ISG to BBF yesterday. And that was a great summary, Chris. Thank you. It basically said we're going to suspend all work on the disaggregated BNG here. Forces, I can tell you, was a topic for discussion within the broadband forum. And while there has been a protocol selection done for the control plane to user plane protocol, which is PFCP, there's been 2 liaisons from BBF to IETF stating such. Topics like this are always welcome in that venue.
Thanks. We want to showcase the importance of having a data model actually to support the protocol. That's one.
I'm sorry, I can't hear you. There's a full-blown discussion in back of me.
I think the importance of this talk is that to showcase that having a data model alongside the protocol is pretty useful, and it can support more than simply the separation, but can add more functionality
and there is work. There's also work there going on regarding the data model and the management plane as well. So
I'd like to see some kind.
I can talk to you offline about some of the detail. Thanks.
So Dan Bogdanovic, I would be interested to see more on a distributed architecture for a BNG, but that would be, for start, implementation independent, unless you really have an implementation that you can present the results of that.
Okay, thanks for your comment. Sure.
Diego Lopez Telefónica. I'm not in the front page, but I feel myself one of the accomplices of Evangelos for preparing this. And our original intent when we started talking about this was precisely, it's not only about BNGs, and this is why I believe that this current title, current focus is somehow connected to this statement for the ISG, but our intention was precisely to explore the idea of a unified mechanisms for access.
Yes.
Call it BNGs, call it whatever the 3GPP call it on the in 5G, call it what you use for cable connections. Is in general for the access side of the internet. That this for us is extremely important.
Yes, so it's the BNGs usually most of as a use case that we can showcase the use of forces as well, right?
Greg Mirsky, ZT, pretty much concur with the previous statement that there are a lot of things that can benefit from their control user plane separation. So I think that the right way thing would be is just to look at them, whether it's access network specifically, and then get the requirements, agree on the requirements, and see what the generality we can produce. Again, without any specifics of talking about distributed BNG.
I was going to concur with the rest, but I'm not going to repeat that. I have a question for you. So how does the decision, I saw the report in regards to forces and the BBF, and it didn't seem to be,
talking to the microphone.
The analysis of why forces was considered. I think there was something published. How does the decision get made? Does the BBF contact somebody through you, and then you go and find the forces people and have that discussion? Because I was never informed that the BBF was looking at it. And I've been very
so the liaison statements are public documents. They get sent.
I'm talking about the process. what is the process that the BBF is
Right.
probably
So the
looking-
process involves these public liaison statements. And then
I don't think-
within,
I'm not, you're not understanding my question. What is the process for the BBF to request the IETF that they were evaluating forces?
so I suggest we take that offline because that's BBF process business that we really don't know about. And you can discuss it offline with someone, but it's not really our business.
Okay, thank you. So I have one less comment to make. Okay. I will say, as a quite kind of a public service announcement, which I didn't cover in the last time I was at this mic, the Broadband Forum has actually changed their operating, I would say operating procedures, but it's not really procedures. They've changed their bylaws such that now anyone can approach the Broadband Forum, pay a subscription fee or an access fee, and get access to all of their work in progress. They are now nearly as open as the IETF for a small fee.
Okay, thanks for that update. So since we've had, okay, we'll have one more comment related to the, and a possible follow-up from Dave, should it be required, on the liaison statement and that aspect of this, and then we'll let you get on with your actual presentation.
So waiting from China Mobile, you know that there are about 10,000 BGs in our network. The protocol between control plane and user plane is very important for us. When I'm happy to see that there are another solution for these things. Maybe I think it's a good direction. As I know that the solution from the BBF, but they could contain all the requirements of China Mobile. For example, the CDN is not the scope of BBF solution, but the CDN is very important for us because they are lack of private IPv4. So I think this solution is very good. And then maybe I will talk about the details of the meeting.
Okay, so
Okay, thank you.
I had a hard time little understanding you. I couldn't hear very well.
So I think the last statement was she'll talk to you after this meeting directly. So that would be good to follow up on. I think she likes the idea and would. So let's cut this off here, and you two talk after the meeting.
The requirement of the DBD is very clear for us. Yeah, I will give you the use case.
Let's talk after the meeting.
Yeah.
Okay, thanks. I have a hard time understanding you. Sorry.
Hi. So Dave Senkrop again, liaison manager of the BBF. If there are requirements, I mean, the document was sent over in one of the liaisons, the latest liaison. I would encourage people to take a look at it, review it. If there are requirements that need to be covered or should people feel are missing, that process is still open in the BBF. So feel free to approach them.
Thank you.
For a reasonable fee.
I'm sorry, what? I missed
that. Nothing.
So I should ignore him as usual?
Exactly.
Okay.
Okay, please proceed. Thank you.
Thank you very much. So thanks, Diego, for bringing that up. So the BNG is actually a use case that we want to showcase that we can support multiple access types and multiple scenarios. How many of you know forces? Can I see a show of hands? Okay. So I'll just do a very brief intro. So forces is an IETF solution for some time ago. There are a couple of RFCs already published. We had 2 successful interoperability tests. And Forces has a number of features like availability, publish subscribes, and request response. I think the most important is that the protocol is independent of the model. Forces models the functions of the data plane using what we call the logical functional block. So it's an abstraction of the functions of the data plane. The forces model is object-oriented and has several advantages of this, like we have inheritance, we have augmentations. So a developer can define the components, capabilities, and events of a data plane function, and it can manipulate that, and which the components, and which actually change the behavior of the data path program. So packets come in on optional metadata, and they are being altered by the data path program, possibly, and exit as additional metadata or changed, and proceed to the next LFB class. So we have LFB classes that are instantiated and connected into a graph, which actually creates a service. So why forces? It's an existing IETF solution. It has been proven, it has been used. It provides a data model that can support, it is extensible. It allows you to define, among other things, capabilities and events. LFB graphs can be dynamic, so a control plane application can actually change the behavior and change the services that exist in the foreign plane. It can natively support any type of access, as we said before, and we'll showcase how. And as I said before, any new LFB included into the foreign plane does not have any impact on the protocol. Right? So we can add as many new existing or new LFBs, and the protocol is going to stay the same. So as we said before, we use the BNG as a use case, and we took a look at the PPOE as an example. So, for example, we have port LFBs that have incoming traffic, and based on specific values of ether type and the PPP control field, this will be needed to be sent to the control plane to be handled by some kind of tunneling infrastructures, which could be VXLAN, GRE, or even forces supports a way to transport to the control plane, which will then be sent back into the data plane to be sent to the subscriber side. Right. So when the user has been authenticated and authorized to use the to proceed to the network, then the control plane is going to program the classifier in order to allow the subscriber traffic to pass through. It goes through the classifier, through the PPO LFB, in order to decapsulate the PPPoE headers, IPv routing to discover the next hop, and then goes out into the network. On the way back, of course, we have a similar kind of graph of LFBs. So it goes through an instance of LFB class, goes through the classifier LFB, back to, it discovers that this is for a specific user has been subscribed based on the destination IP address, goes to the IPv routing LFB, goes to the PPPoE LFB to be encapsulated in PPPoE packets out of the port LFB towards the subscriber side. Right. So once traffic goes through the VBNG, we need to be able to monitor the traffic in order to find, get statistics and possibly usage measurements in order to do accounting. There are a number of ways this can be done via forces. You could actually, the control plane could poll the foreign plane, and for example, the PPPoE LFB could hold stats, or the control plane could subscribe to events for statistics, so it can get notifications for statistics. Or even better, another solution would be to create a specific LFB for that for monitoring. Right. As we said before, we can Forces supports any kind of access type and can do that by simply creating different LFB classes that will be able to handle the different kind of access types, right? And this, as I said before, has no impact on the protocol. The protocol has specific verbs, set, get, delete, and it manipulates components inside the LFB class. Whatever, as long as it is modeled using the Forces model, the Forces protocol is able to handle that. Right. So now, that was a brief view of simply connectivity service. So what happens if we want to have new service into the BNG? So we can simply add new LFBs into the graph. Right? For example, for a bandwidth management service, we can add a policer LFB, or we can have a quota enforcement service. And again, this has no impact at all for the protocol. So, and this is an example for, so we can simply add an LFB into an existing graph, and we can so that we can have a bandwidth management service, and similarly for the downstream traffic. Right. And we can even go one step further and have specific services for specific users. Right? We can classify a user based on some characteristic like a service type or whatever, based on IP address or MAC address. And this one, the classifier will select the next LFB that's going to be a next graph of LFBs that the specific user is going to be handled. So we can have specific services for specific users, right? And similarly for the downstream and upstream traffic, right? So again, having a data model is quite useful in order to be able to support this kind of activities, so that the protocol is not going to be changed. It's not going to be changed by any changes of new services or new functions that we want to add. Yes, thank you.
Yes, question, Louis Chen from Juniper.
Yes.
To standardize a protocol in between is a very big challenge. The reason why I say that is, if you look at so many radius attributes for each vendor, it's over 100 radius attributes. That means different functions due to different hardware implementations. And you want to standardize it. How do you do it? Because radius, already you have different radius kind of attributes, meaning different implementations in different vendors. Only a very small set of standard attributes today in IETF for the radius sections. All the rest is AVP or special attributes, vendor-specific attributes, VSA. So how you standardize this?
Right.
The second question actually is, you want to standardize something which is also difficult to see, is like a line card reboot. A line card crash, instead of, dropping thousands of users, you still send a message, one message to the control plane. How you digest those messages, standardize that one, is another problem for me. For me to see actually this system.
Okay, so for the first question, if I understand correctly, you say, how do you standardize the connection to the radius server?
No, sorry.
Yeah, go ahead.
What I'm saying actually, because today radius is the major one using, right?
Yes.
And already different vendor has a very big dictionary, VSA, which is very vendor-specific kind of things. Only a very small portion is standardized. Right now, you're going to standardize all these things using one protocol. That means every vendor needs to use the same dictionary, which is difficult.
So I think
you're talking about, I think he's talking about the control path.
Yes,
right?
you think about
using radius. That doesn't change.
Yeah,
Nothing changes there.
Understand, but then the
Guys, either talk to the mic or take it
The
out.
protocol is an IETF standard already.
Yeah,
it's already standardized.
Yeah, I need to force the information, translate the radius.
Microphone.
You need to translate all this kind of radius from a control plane to into the forwarding plane, and that may have vendor-specific things, right?
Hold on a sec. So there is no data path to control path for using radius. Radius is a subscriber management, right?
But you still need to enforce. So you still need to enforce enforce it in some way, right? you need to program the kind of things into the forwarding plane. And that one actually you have to you understand, it's not so simple.
So,
Let's take it out of, let's take it out of here.
okay. So, well, yeah, we'll let that pass. Okay.
Dejan Bogdanovic. So on the, no, not this, okay. First of all, one of the things which, my brain is now completely fried down. Having a fixed set of basic primitives and then adding vendor extensions on top of it makes, in general, the community life easier, because they're saying we have a certain semantics and syntax that we can all use, and then we can do vendor extensions on top of that. On that part, I agree. And Luis said that, this thing with the radius is a good example, because there are a few common ones and then many vendor-specific ones. That's a pretty good approach, and I personally like that approach to be move forward. There are two things what I have with the with the forces. I like the idea. Their question is there a implementation? Because there are other frameworks like that where you can model the data plane and put it into that are much more used. And if you could explain why forces is better than the other existing frameworks that are getting a lot of traction within the industry, then we can evaluate that. So I can use Cap and Proto to model the data plane and expose it up North Stream. So why there are plenty of other ones, and I can say, let me finish now, and then I'm asking him, I'm not asking you.
Yep.
I'm asking him.
Yeah, go ahead.
So if you can say the combination, if you can do the comparison, why this versus the other, what are the benefits of using this versus the others, I'm happy with that, to consider it.
Okay.
So maybe there's a slide on that, right? As why you want to use forces.
Right. So forces actually is.
So I think we're gonna let
protographs are not an
them
IETF
respond,
standard, neither is
and
it
then
French.
so
This is an
respond
IETF standard.
to the mic, and then we're gonna shut down the discussion.
Thanks.
Okay. Thanks.
So forces is not only a way to package things together and send it to the other side, right? So it's not only about doing serialization and deserialization. It has it's an architecture, right? It has the model, it has the protocol. The protocol has already specific capabilities, like as we said, high availability, event subscriptions. It is transport layer agnostic. You can have augmentations of models. You can do all these kind of things. So it's not about serialization and deserialization. Right? So from what I understand from Cap and Proto or any other serialization, deserialization, you have to develop all these kind of features from, you have to actually develop this, right? Forces inherently supports all this.
What you're
We'll
listing
let you
here-
do
so-
one quick
so-
response, but not like future question.
Except being the IETF protocol, the other things that you're putting down here, I can use the existing frameworks that are already out there. I just mentioned one.
Okay.
Okay, a 30-second rebuttal.
Okay, just a quick 30 seconds. Okay, so they're not IETF standards. This is an IETF standard. It has been vetted here for many years. Sure, you can go and implement your own thing, and you can get 100 of your friends to work on it. This is a standard. It's been deployed. It's well understood. It's gotten a lot of scrutiny here at the IETF.
Okay, we don't need to continue the discussion. Thanks a lot. It was very thought-provoking and timely. So next up, we have Changfeng Ji presenting.
Yeah, I would really appreciate if you cut the marketing and keep on really describing what's happening, okay? Because slides have marketing to some degree.
Okay.
You could use it.
Hello everyone. My name is Xie Zhongfeng of China Telecom. It's my pleasure to share some experience about SRv6 deployment of several operators. This draft is about SRv6 considerations. Actually, it has a relationship with one other draft is the SRv6 deployment status. It introduced progress. This draft introduced progress as SRv6 industry, including deployments, implementations, academic contributors, and incorporated tests. And as you maybe know that there are seven deployments worldwide: SoftBank, China Telecom, China Unicom, and Sonet, etc. And in our draft, we mainly introduce deployment suggestions, provide some suggest about network transition and solutions to in some specific scenarios. We also introduce detailed about experience of SRv6 deployment, where the earlier draft gives some deployment status and the features, at least the features of the SRv6 deployments. And we all know that IPv6 developed quickly during the past several years, including China, and major operator has deployed IPv6 nationwide, so which give a strong foundations for SRv6 deployment. We all know that SRv6 has the following advantage: is that first is that IPv6 route aggregation. This is compared with MPLS, SR-MPLS, because in SR-MPLS it will adopt 32 bits segment, which will be advertised across all the domain network. But in SRv6, because it uses native IPv6 features, so the route can be aggregated to reduce the issue of the routing issues, scalability issues. So we also can say that SRv6 provide end-to-end end-to-end service auto start, which means service agility, because for SR-MPLS, it need to upgrade all the node to support support the capability. But in SRv6, we only need to can be deployed based on actual requirements of the based on the operators. Then we all know that SRv6 can be on-demand upgrade, which reduce the service provisioning time, and so we can say that SR has several advantages. This draft also gives some deployment guidance for SRv6 deployments. We all know that there's two options for this network transition. The first one is from IP-MPLS to IPv6, then SRv6. And the second one is from IP-MPLS to SR-MPLS and to SRv6. So from our experience, we think that the first one may be more natural and straightforward. So we recommend. So right now we recommend the option one. It is very simple that we should make all the network to be IPv6 capable, as what we have done right now. So then secondly, we need to upgrade some edge routers, some edge device to be SRv6 capable based on the actual demand of the service. Then next, we upgrade the network to in the immediate node, in some of the immediate node to support to support IPv6, to support SRv6 to enable traffic engineering, and SF6, etc. Then next, we will plan to upgrade all the network to be end-to-end SRv6. So SRv6, this case has been mentioned several times. Just SPv6 in China, field trial in China Telecom. Actually, it's in Sichuan province. This Sichuan is a very big province. It's similar to the size of Germany. So in this case, we depend on the architecture of the whole network. In China Telecom, we have two backbones, IP backbones. One is 163, which is a native IP network. Of course, it is IPv4 and IPv6 stack, which provide many internet access service and IDC service, and also some mobile internet services, etc. And the other backbone is SYN2, which provide which is MPLS based. It mainly provides some kind of service to enterprise users. So in traditional approach, maybe this traditional approach, the enterprise service carries SYN2, but differently in this case, the video traffic for the interconnection, the video platform interconnection is carried in 163 because 163 provide abundant bandwidth, which can meet the requirements of the video service. So in order to deploy service quickly, we implement PE routers to be SRv6 capable. So we can provide service quickly in short time, which improves the service provisioning, providers improve the speed of the service provisioning. The second deployment case is China Unicom. The backbone of China Unicom is 169. It's called 169. Actually, it's a number. In this case, it mainly uses SRv6 has been adopted for the interconnection of cloud data centers. The cloud data center actually is similar to China Telecom to some extent. So in this case, because the backbone network has IPv6 rider all over the country, including the metro network. So we have some end-to-end IPv6 foundation network for SRv6 deployment. So in this case, we deploy PE equipment to make it enable SRv6 for the SF deployment. Any question?
Yeah, real quick question. This is Dino. Can you put values to smoothly and quick?
Sorry.
You said it smoothly migrates. Can you put some data behind it so we can judge what's smooth and what's not smooth and how quick you switched over?
You mean the switch over migration?
Yeah, when the one in the last slide, when 163 went down, how long did it take you to get to the other one?
You mean the speed, right?
Yeah, in time.
In time,
milliseconds, seconds, hundreds of milliseconds.
It's not a second. Actually, because this is a service for enterprise users. Traditionally, we maybe take more than 1 month because we need to undergo some kind of procedure. It's a long time. But now, maybe several days, this service can be provided to customer. This is not for ordinary users. Okay.
Did you do any measurements on the switchover time?
Not yet.
Okay.
Okay.
Hi, Tony Lee. It seems like most of what you're doing here is all just VPN stuff. Is there any actual TE going on here?
It has not been, TE maybe is on the agenda, has not been done yet.
Okay, so you could be doing this with something much simpler than SRv6, yes?
Yes, maybe in the future.
Okay, so then how much bandwidth did you waste to get this VPN?
How much bandwidth, you mean, right? In China Telecom, the service, the bandwidth service range from gigabits to 10 gig. So it's a large range for the bandwidth.
You seems like you could have been doing this with a much simpler, lower bandwidth VPN solution. Did you compute how much extra bandwidth this is taking?
This is Robin, Tony, I understand. So I think the benefit I think is explained here is across multiple domain. Yeah, because you know here, this you mentioned that the backbone is the IP, the pure IP. So that's the difficult to deploy VPN.
You can run GRE
It can
over
take a long time
IPv4
to-
across domains just fine today.
Okay, Tony, so we offline?
So in China Unicom, it set up the P equipment to be SRVs capable, so that VPN traffic can be traversed from one autonomous system to another, which means from, for example, from Beijing to Guangdong province. And also we all know that Guangdong province has also implemented SRv6 based VPN service in Guangzhou, Shenzhen, and Dongguan cities. So based on our experience, SRv6 has shown its advantage in terms of service agility and incremental migration. So we think that SRv6 is very attractive and very valuable for the future network deployment. Of course, it needs more deployment cases for the evaluation, and maybe we need to for the maturity of the network in the future. It can also be used for 5G transport and data centers, etc. So we hope that based on more experience, more input will be provided for such as IPv6 address, SRVS locator, and SRVS SID design policy, etc. So we welcome any more feedbacks and cooperations in the future. Thank you. That's all.
Real quick question. How many SRv6 hops do you anticipate you would deploy?
You mean SRv6?
Yes.
Or IPv6? Okay, IPv6.
How many SIDs would be in the SRH header?
SI? Sorry.
How many hops in the source route do you anticipate with a network deployment?
Dino, answer this question. So, and in fact, now that is only the edge node. There's no SRH now. Yeah, because the VPN. For the VPN, there's no SRH.
Yeah, no SRH.
Yeah, but then we will think about that the loose hop, loose
Okay.
PE.
Can you
That
answer
maybe-
the question just in general?
Yeah.
When you
General, I
deploy
think.
it, how many hops do you think would be?
Yeah, I think that's the backbone. We think about that is the 5 to 6, and the maximum maybe 10.
30?
10.
Did you say 30?
Sorry.
30 hops in the SRH times 16 bytes? Are you going to give your user any data?
106 bytes.
Huh?
106 bytes.
106
10
bytes?
segment. 10 segment. Yeah.
David Dai from CICT. Can you scroll back to the slide with the incremental deployment? Yeah, this one. And the step one is from your side, the upgrade to IPv6. And to my understanding, the update from IPv4 to IPv6 maybe from the core network is first. And your step two is upgrade to the edge device first. So my question is, if we just update the IPv4 from the core network and with the edge network key staying in the IPv4 before, then what's your consideration for these application scenarios?
My understanding is that in our case, because IPv6 has been realized everywhere, IPv6 has been ready every part of the network. So we think that maybe this transition from IPv6 and SRv6 will be a better choice than SRMPS. But maybe for other operators, they will have their specific requirements for network requirements. Maybe SRMPS will be a better choice. That's my understanding.
Thank you. My suggestion is maybe in some application scenarios, we update the edge device first. And to the other application scenarios, maybe we update the core devices first. That's my suggestion.
Yeah.
Thank you.
It depends on the actual scenario. Okay.
Wim Hendricks, Nokia. Can you go back to the slide where you do the comparison on the? Yeah, I think here you're comparing native MPLS, but there is also implementations where you do segment routing MPLS over IP. And if you would take this comparison into account, all your things are actually not true what is here. So you're comparing just one thing from the other, but there is other ways to achieve that, in which case this analysis is not 100% up to date with all the capabilities which we have available in the IETF.
Okay, actually this is not actually for an absolute comparison of two technology. I think maybe in some cases SRMPS will has its advantage over SRv6. So this depends, as I has mentioned, this depends on the actual use case.
I just want to point out that you're confusing people who are reading this.
Yes, maybe
it's not. I think if you want to document how you are migrating to SRv6, I think that's okay to do. But I think just make sure that you compare the full spectrum if you do a comparison.
Oh, okay, thank you. We made some adjustment, necessary adjustment.
Satoru from SoftBank. Thank you for sharing your experience of deployment in detail. I just make some comment. I'm really happy to see your deployment not on the greenfield. So many people claim that, hey, SRv6 require fully greenfield deployment case, but you show a good example that SRv6 doesn't require greenfield to be deployed. And also, if you have some chance to introduce TE feature, I saw some discussion here. But if you consider that some control plane technique like flex algo or something to abstract this intent topology or path, so it would be a good idea to reduce the size of the seed and the number of seed in the packet. I think you can still keep the one seed in just IPv6 destination address in the IPv6 header. That would be fine to do the traffic engineering feature, even for the interdomain case, if the interdomain flex algo is possible. Thanks.
Yes, right. So this depends on the progress of the compressed SRv6 standard.
Okay, so compress a little bit scare me that when we mentioned that compressed header discussion, so not to reduce the header itself, but put the multiple semantics in just 128-bit field. That would be my point.
Okay.
Okay, well, thanks a lot.
Thank you.
So thanks, and all deployment cases are very useful. Please keep them bringing. And personally, I would be really interested to see migration from T-based networks or CPT, where, for example, reservation is done in band versus moving to computation is done off, and how people solve problems with regards to bandwidth resource reservation. Kind of stuff would be really interesting use cases to discuss here.
Yeah, so next up is Waimo Chen.
Hello, everyone. I'm Huan Chen from FutureWay. Today, I'm going to talk about the SRT pass meter point fast protection. So first, let's give an overview. So we have existing fast FR for meter point. However, when a meter point of SR pass fails, the traffic will lost for some time, even though the existing FR for meter point is used. So our solution is provide a protection for that period of time. That means that with our solution, the failure of a meter point of SR pass will be fully protected. So here, in this figure, we give an example. For example, we have a SR pass from node B to node C. So we go through node N and node C. So when node N fails, so node P will provide faster protections. However, when IGP converges, the traffic will get lost because after IGP convergence, node B will not have routes to node N. So for the traffic go through node N to node C, those traffic were dropped. Only after another new pass, new end-to-end pass from B to C is installed on the B, and then traffic is recovered. So we can see that the traffic get lost from the point at which the IGP converges until the new end-to-end pass is installed. So for those period of time, which are marked by the red line, that during that period of time, the traffic gets lost. So our solution is provide fast protections against the midpoint failures for that period of time. So with our protection, the failure of a middle point is fully protected. So basically, we have a revision of several versions. So updates to the previous version is that we changed the title as suggested. So originally we use a segment routing, proxy forwarding. So right now we use a SRT pass midpoint protection. So this is is better than the previous one. In addition to that, so originally we use router capability TLV to distribute the capabilities for proxy forwarding. So we changed that one to router functional capability TLVs. So this one, I think this one is much better than the previous one. So in addition to that, we add sections, security considerations, and IANA considerations, and then some editorial changes. So any comments and suggestions?
Louis Chen from Juniper. I do foresee that actually it's a good thing to have a PRR for this kind of operations, but there's an issue actually. I'm not sure because the diagram is a very simple one. Is it possible that's because IGP, the synchronization kind of timing sequence, it was possible there's some kind of drops actually during the switching. So even your PRR, you still have trouble of that one. It's like a micro loop problem. Micro looping avoidance problem actually is similar there. Later on I can tell you actually offline, but this is possible.
Looks like the issue you mentioned that is invisible because this one is we can see, just look this example. So when node N fails, then node P will provide fast protections. And then IGP convergence, whatever convergence, so we can focus on the node B.
Correct. I'm saying actually, when the IGP progress, there will be a different update of the state, and due to synchronization of the control plane, synchronization of the forwarding plane and control plane, there will be a little bit issues there. I will show you later on actually.
Yeah, I think that one is minimum. Is a minimum. I see. But this one maybe you have some very tiny in synchronized.
What I'm saying actually, there will be possible packet loss during that time.
Yeah, no,
Okay, you have
I
PLR,
got you, yeah,
but still you have a possible packet loss during something like a make loop avoidance problem.
Yeah, that's the IGP in sync for some period of time, but those one here is our focus is this big period of time. So that minor micro loop may be there because that's a IGP in sync for a short period of time. I got that.
Martin Hornefer, Deutsche Telekom. Have you considered that in many cases just using any cast groups for the midpoints might solve the problem as well, maybe even faster?
Yeah, for any cast, I think that there are some issues. I think we consider that those are any cast solutions.
What are the big issues with Anycast?
Yeah, offline, I can give more details.
Yeah, but
to you.
Martin, depending on your network design, you can't always use Anycast. How do you place your Anycast? It's on some networks. Yes, it's doable, but not always, I think.
Well, I said it may be useful or feasible for many cases. I'm not saying it solves all the cases.
Okay.
Yeah, I got you. I think for egress, use Anycast is one solution. But even for egress, there are a couple of issues. And for midpoint, yes, I think maybe use Anycast, maybe it's hard.
Yeah. Stefan Likowski, can't you just try to solve it by just delaying the delation of your ILM?
No, this is not by delaying. Yeah, this is in the sense that
if P and B are just delaying the delation of the ILM to N?
No, this is not delayed. So detailed solution like this way. So node P will distribute its capability for proxy forwarding.
No. I'm not talking about your solution. I'm talking about something else, which is just P and B are all seeing that N is disappearing from the LSDB. Just keep the ILM programmed in the forwarding for a couple of seconds.
I can't get your question. Can you say your question in more detail?
Yeah,
what's the issue?
just try to keep your forwarding entry programmed in the hardware.
No, this is not keep a traditional IP forwarding entry.
So
here the solution is that.
One more. So I think there's a miscommunication here. What Stefan is asking is he understands what the solution you're proposing. He's asking why not instead use a different solution that delays the installation of basically of the black hole or of the black holing the traffic when you have no entry. Basically, keep the old node SID entry.
Yeah, that's a good question. I think Stefano's solution or proposal is that we're just keeping the older IP forwarding, right?
Not IP forwarding, MPLS forwarding, not IP. You can delete IP, but you need to keep MPLS because we solved this kind of issues in LDP convergence with just delaying the label withdrawal or label drop in the forwarding.
Yeah, that's what our solution. That's what we propose here. So this one basically.
No, because you are also advertising a lot of stuff, but you can just keep forwarding and just drop control plane.
I got you because the idea is that we want to keep those forwarding for SID, but how we achieve that? So we need to have some ways to let some nodes know, or keep this forwarding entry for me for some time.
I'm not sure that you need to keep a control plane. You can just keep the forwarding without any control.
Yeah. Even so, we want to keep a forwarding plane. We need to let those people know that those nodes know keep a forwarding entry for me for some time, right?
Stuart, so this is an incredibly common scenario. Egress protection like this is what you're trying to do. I'm still puzzled as to why there isn't a more elegant solution involving Anycast. So in that particular scenario, presumably you should use an Anycast SID for N, in which case ordinary fast reroute would sort the whole problem out.
No, ordinary, so this one,
Oh, hang on a second.
ordinary doesn't,
Well,
cannot resolve this
let me
one.
explain it then, right? So P discovers that it can't get to N anymore. All right. So P is going to does a fast reroute to N prime, which is, well, the N's anycast address, which should get it to N1. Once it's at N1, it will go to C because that's the next SID. So I would have thought you could have built an anycast solution for this standard, very common scenario, and it would have just worked.
So I think if you have some solution using anycast, so I would like to you propose details and then we can discuss either offline or on the list.
Yeah, so I certainly, this is Dino, I certainly support the idea. And there's a lot of reasons why. Because if the SID is an anycast address and you have to reroute, the head end doesn't have to change the SRH. This is very useful. And if you're always routing to N, the anycast address, and you lose a route to the top N, you never have to delete anything from the fib or any forwarding table because N will just stay there. The next hop just changes.
Yeah, I think for anycast, there's a couple of issues. I think one is that anycast may have a routing loops. And also, I think we found some issues there. So if I think roughly you can say, oh, we can use anycast. Give detailed solutions, and then we can discuss.
So the other concern I've got, and it's a concern I've always got with these sorts of solutions, is that we reduce it to a sort of trivial cartoon case. When you apply this to a real network with multiple hops in there, then it very quickly breaks down. But if you could anycast to the two exits, then ordinary fast reroute followed by ordinary reconversions would mean that you could deal with any failure in getting from A to the N.
Yeah, in theory, or we have some issues there because we already have pictures or figures to show those issues. So if you have time, I can show you
Please state the issues. It would be useful if people could hear what the issues are.
Yeah, I think for the egress,
just be brief.
Yeah, for the egress one, I already sent those issues on the mailing list. So I think you guys propose solutions, give detailed solutions for anycast.
No. Discuss. So have the issues with anycast been stated on the list?
Yeah, you can see.
Have they been stated? You're going to just go and look at the list and I'll find the argument.
So those issues for egress protection use anycast. I send the issues on the list, Rtgwg and Sprint.
Well, you sent one last night, which basically said there are issues. I'd like to know what the actual issue is.
Yeah, those issues I already sent. I think last night.
Yeah, the one that last night just said there are issues. It didn't say specifically what the failure cases were.
Actually, I don't mean to defend this, but
one issue is a routing loop.
But
if you use anycast, they may cause some routing loops.
The reason anycast SID will not solve this Jenkins lateral from Siena, before N1 and N, you need one anycast to go to C. If you are going to D, you have another N and N2, another anycast for that. Basically, where you go will change how many anycasts you will need, just will not scale.
So, you see the working group is clearly demanding comparison between any cassette that you're proposing. And the best way to address it is to address in the draft, not sending emails to mailing list. Please have comparison section where you compare what working group is proposing versus what you're proposing with benefits of your proposal.
Okay, we can discuss about the one, anycast. Okay, anycast solutions. Yeah.
Peter?
Yeah, I'm still allowed to make a comment?
Absolutely.
So just for the anycast, maybe I just discussed with Stuart. So the anycast would work if we are doing egress protection, but what Zebu is trying to do is trying to protect the SID in the middle of the SID which is in the middle of the SRT stack, right? So it can be like a P node, which is in the stack. Now that fails. It's not the egress node anymore. So that's why you can't have like, what would you do anycast? Every node would have an anycast with some other node. Well, with 1,000 nodes in a network, yes. But yeah, but then you would have to have 1,000 anycast addresses as well. Yeah, wow. Yep. Okay.
Just one comment. If you don't want us to design a good network, we could do it here if you want. But the thing is if you're using IPv6 and you have link local, you don't need unique global addresses. So you use link local addresses to realize your IGP, and then all the addresses have unicast at each hierarchy.
So I have one comment here. So there is an alternate proposal in Spring Working Group for node protection for SRT paths that talks about the Anycast solution, as well as the keeping the forwarding plane for a longer time. The proposal that Stephen talked about is explained in the draft. I would request everyone to take a look. Thank you.
Yeah, thank you. We can look into those drafts.
Yeah, Louis Chen from Juniper. I think we need both solutions, in Anycast and non-Anycast, because reason why, if Anycast is no longer TE anymore, not TE actually, no traffic engineering.
So observation here, first we need to decide with Spring Working Group chairs where we do this work, because it's partially belong here because it's faster route, partially in Spring because it's segment routing, and then potentially we should be able to conversion solutions and decide whether we need both or we agree on something that's addressing everything. And so to your next comment with regards to adoption, we do need to discuss with Spring Working Group what we do and where this will progress.
Okay, thank you.
Thank you.
Next up is Bo Wu.
I'm here to give an update of this IETF up-young model on behalf of the other authors. Here is this up-young model cover, because the existing IETF IP model just covers the basic enable, like basic static enable MAC entry, but this app model covers more bits of app implementation, like proxy app or gracious app. And we add more like app statistics. And here is the current app tree. And here is the changes since like IETF 104, and we just add more editorial improvements to the young modules and security sections. And also based on 104 discussion, we removed app specific discontinuity timestamp added in the 02 version. And so, but we added description to refer to the interface one. And we added proxy app and gracious app example, and we also removed app dynamic learning example because that was a quite obvious one. And so this is all the changes. And we think that we already solved all the remaining issues. So we think that the next step is that we solicit more comments on this draft, and also waiting for the working group last call.
Jeff Haas, I've read multiple versions of this draft. We are doing a steady swirl through, just simply addressing small issues. I would like to suggest to the chairs that this was ready to go probably 3 versions ago, and that a working group last call would probably push these to completion a lot faster.
Okay, so.
Himanshu from Siena, I have a quick clarification question. Is static ARP covered in the base IP interface draft or in this one?
It's already covered in IP model.
It is covered? Okay.
Yes. Okay.
So I'm happy about the shape model taken, and it's definitely almost ready, I would say. I was promised last update from the co-authors, and I'll start initiating young doctor reviews and normal process to further progress the draft. And thank you for the good work.
Okay, thank you.
thank you everyone for being here. And if someone hasn't signed, please do so. And we'll see you in Vancouver. And safe travel back home.
Yeah, the blue sheets are up here at the front, being waved in the air. If you haven't signed, please do.
Okay, yeah, fine.
That's fine. So I'm here around and I will be here until 2 p.m. I will be in Grove, so I will be here until 2 p.m. I just want to make sure that it's fine. You come to Grove. I can. Oh no, I'm going into the headquarters.